Hi there, everybody. Let's get right into female reproductive system, and we're going to talk about the ovaries in this video. We're going to talk about the ovaries and oogenesis. So the ovaries are paired organs in the pelvic cavity. They have two major jobs. They are the site of oogenesis, so we produce all of our eggs in our ovaries, and they release hormones that help with oogenesis as well as with producing secondary sexual characteristics in females and helping to maintain healthy levels of calcium in the body and stuff like that. The ovaries are held are held in place by multiple ligaments, and so this doesn't really show those ligaments, but I have the ligaments listed. We have a mesovarium, a broad ligament, an ovarian ligament, and a suspensory ligament that hold the ovaries in place. And you can see each ovary on the sides, okay? This is not, obviously, this doesn't come from our book. It comes from this website. So the ovaries are the site of oogenesis. Oogenesis is the production of female sex cells. And the function is to produce eggs that can get fertilized. This occurs throughout a female's life. It doesn't occur at one specific time. It doesn't start at puberty and end at death. It starts actually prior to birth. So we produce all of the eggs that we will ever have before we're even born. Our ovaries are packed with those tiny little oocytes. So the ovary contains a germ cell known as an oogonium. This oogonium is a diploid cell, and these are what divide via mitosis to produce primary oocytes. Every primary oocyte gets arrested, so it stops growing. It just kind of goes into a dormant phase and sits in the ovaries in prophase 1. So prophase 1 of meiosis is the stage where the homologous chromosomes come together and crossing over occurs. And at that stage, the ovaries or the eggs, I should say primary oocytes, stop growing. And they just sit there and wait until puberty. So this is prior to birth. We have all these eggs. Each of our ovaries has between 1 and 1.5 million eggs in them. But by the time we hit puberty, we will have very few eggs left compared to that number, at least. So the ovaries are inactive during childhood, infancy and childhood. Most of the eggs will regress. They will basically break down. This is known as atresia. So by puberty, we're only going to have about 400,000, that should be as 400 with 000, follicles remaining. So that's 400,000 primary oocytes that are going to be released over the period of from puberty until menopause. Sounds like a lot, but it's really not that many. So what happens to females? Females start puberty anywhere between age 11 and 15 years of age. When they start, or to start puberty, the hypothalamus starts releasing a lot of the GnRH. So this stimulates the anterior pituitary gland to secrete follicle-stimulating hormone and luteinizing hormone. Follicle-stimulating hormone stimulates the ovarian follicles to become active. Luteinizing hormone stimulates estrogen production. Estrogen helps in supporting the growing egg, but it also prepares the uterus for progesterone, which will start being produced as soon as the follicle, the oocyte, is released into the fallopian tubes. So this is a very cyclic pattern. It happens every single month from puberty until menopause, and there are 3 phases. This is known as the ovarian cycle. The follicular stage, where the follicles get activated, the ovulatory phase, where one specific follicle ovulates and gets released into the fallopian tubes. Hold on one second. As I was saying, the ovulatory phase, where one secondary oocyte gets released into the fallopian tubes, and then the luteal phase, where the corpus luteum will produce progesterone to continue keeping the, or to prepare the uterus for implantation of the fertilized egg. So here you can see different follicles. So these are primordial follicles that will eventually become the primary follicles. Days 1 through 13 of a typical 28-day cycle. Not everybody has a 28-day cycle, but this is the most common, so we use that. Are going to be known as the follicular stage. And it's during this time where a couple dozen oocytes get woken up. So luteinizing hormone gets released, follicle stimulating hormone gets released, follicle stimulating hormone stimulates a couple dozen of your follicles. The follicular cells then start releasing the hormone inhibin. This inhibits further follicle stimulating hormone. So we don't activate all of our eggs at one time. We don't need that many eggs being released or activated. So a couple dozen eggs get stimulated every single month, but only one egg is going to get nourished. The other eggs are kind of like helper eggs, right? So most of the eggs are called, or the eggs are known as primary follicles. And only one is going to mature in general, and it says few because sometimes you can have 2, and there are even periods where you might have 3 eggs that will naturally mature into secondary follicles or secondary oocytes. So usually only one that will go or will become a secondary follicle and then mature into a vesicular follicle. And so this is that vesicular follicle right here, also known as a tertiary follicle. This vesicular follicle has multiple cells surrounding it, known as thecal cells. These thecal cells are protective cells. They're cells that basically keep the oocyte or surround the oocyte and keep any pathogens or anything bad from getting in. They also have to, they also keep sperm out. So, I mean, there are certain things that sperm have to do to get in. Sperm have a hard job to do. They have to get through those thecal cells. They have to get through the oocyte cell membrane before they can actually produce the zygote. And so that vesicular follicle or tertiary follicle is going to move to one end of the entire tertiary structure of vesicular follicle. And then there's going to be an area where there's a lot of fluid surrounding it. So this is called the antrum, and in the antrum there's a lot of fluid. So now you have this fluid-filled antrum with one oocyte pushed to one edge of the entire follicle with thecal cells surrounding. And then on day 14, ovulation occurs. So the primary oocyte during this follicular stage, finishes going through meiosis 1 and enters into meiosis 2. Okay, at the end of meiosis 1, we end up having one secondary oocyte. Remember, in male gametogenesis during spermatogenesis, the male produces a total of 4 non-identical haploid sex cells. In oogenesis, we only produce 1 sex cell. And the other cell that we produce is known as a polar body. It's basically a bag that contains the extra DNA. So it's just genetic material that's going to get resorbed by the cell. Everything else, all the nutrients, everything else goes into that secondary oocyte. And then once it hits that once it starts meiosis 2, it again arrests in meiosis 2 at the metaphyseal plate. And so on day 14, we end up having ovulation occur. And so there's a video here that you can watch. Just click on it and you'll see this video. It's amazing. This is actually a video showing ovulation occurring. You can see the egg coming out. This is that follicle. The egg is being released. And then you can see the surgical instruments just holding back the tissue so you can see the egg being released really well. It's beautiful. So on day 14, ovulation occurs. So what happens is there's a huge surge in luteinizing hormone. This stimulates the antrum to increase in size. It swells really large and then basically bursts open. The oocyte is pushed out, and when it is released, surrounded by those thecal cells, it is pulled in to the fallopian tubes. So the ovaries and the fallopian tubes are not attached to each other, not like it's a hallway and there's only one way or one area for those eggs to move. It's more like it's an open area, right? Like if you go out of, like at an outdoor mall, you walk out of one store, you can go into the store right next to it, or you can move around. So that's kind of like what the fallopian tubes are. They're a nice long hallway that the eggs can move into, and that's where we want them to. And so at the end of the fallopian tubes, we have these long finger-like structures that pull those eggs in, but those eggs could also potentially fall to the floor of the pelvic cavity. So, I mean, there is that potential, which can lead to a lot of other problems. But, so let's just assume this egg makes it to the fallopian tubes. This egg is going to be released, and it's going to enter the fallopian tubes as a secondary oocyte arrested at the metaphyseal plate. So this is where, that's day 14. So day 15 through 28, we go through a phase known as the luteal phase. It's called the luteal phase because the new follicle that is formed, so when this follicle ruptures, the structure that is left is called the corpus luteum. This corpus luteum now starts producing progesterones and estrogens. This helps to maintain or to prepare the uterus for the fertilized egg, for that zygote to be moved in. If fertilization occurs during this phase, the corpus luteum will continue to release progesterone and estrogen. But if by day 28 fertilization does not occur, then the corpus luteum will regress into a corpus albicans, and then will basically be resorbed by the ovaries. And we're going to have a severe decrease, or extreme, I should say, that sounds better, decrease in progesterone and estrogen, and this leads us to the beginning of the cycle. So we start that follicular phase again. it also leads us to our period. So I just mentioned this, but during the corpus luteal or during the luteal phase, corpus luteum regression occurs if we do not have any fertilization. If fertilization occurs, then that corpus luteum will continue to secrete those hormones. But if they don't, or if fertilization doesn't occur, then the luteal phase ends and the follicular stage begins, and also menstruation starts. So typically, women will start their menstruation cycle around age 11 or 12, but some individuals can be as old as 15 before they start their menstruation. So it's just depends on when your body is ready to start menstruating. And so this is the full picture showing folliculogenesis. This is an electron micrograph of a follicle. You can see the thecal cells surrounding the follicle itself. All right, so we talked about oogenesis a little. Oogenesis is female meiosis, and it is an unequal cell division. It also occurs in phases throughout life. So the first phase occurs prior to birth. Females go through oogenesis, and all of the eggs arrest at prophase 1 of meiosis, where each of our ovaries has between 1 and 2 million eggs. Then, once we are born, those eggs, they're still arrested at prophase 1, they will start to degenerate. So atresia occurs. Most of the eggs that were produced degenerate. Only about 400,000 eggs remain viable by the time we hit puberty, anywhere between 11 and 15 years of age. Each month, a couple dozen of those eggs will be activated, and in general, one of those eggs is going to finish going through meiosis 1. And when it does, we produce a single secondary oocyte and a polar body. So the polar body here is typically resorbed by the cell. And it's just a bag of DNA. It's just the excess DNA that we don't need. This oocyte gets all the nutrients. Then we go from secondary oocyte, we go through meiosis 2, and we stop at metaphase 2 of meiosis 2. If fertilization does not occur, the egg will degenerate. But if fertilization occurs, then the egg will finish going through meiosis 2, producing another polar body that gets resorbed, and the end result is the formation of a zygote. I'm going to stop here because this has been an 18-minute video, and that's pretty long, so I'll talk to you guys in a little bit. Bye.